So you can see that this is how you go glutamate down to succinate, which is an intermediate. We're not doing all of that. All I care is that you can go glutamate to GABA. GABA is an important neurotransmitter that when it goes out of whack, you see a lot of different diseases or conditions. It's great that you know that you can follow that it goes to succinate, right? But nope, I only care about this one. So I'm going to put it over here on our short side. Is everybody okay if I erase phenylalanine to tyrosine?
Yeah.
Okay. Okay, so let's draw glutamate or glutamic acid. I don't care what you call it, right? Again, here's our backbone. So if you're stuck, start with the backbone. And then we've got our CH2. And then we're drawing, this is our carboxylic acid end, right? So COO. So this is, and we're converting it to GABA. Sorry for the other ones. So this is our glutamate decarboxylase enzyme. Don't care. I mean, I do care in the sense that if you remember the name of the enzyme, if you know it's a decarboxylase, you're going to know that you're getting rid of carboxylic acid group, right? So I'll put it over here. Okay, so what happens? We now have something else, right? So we've got our COO minus, we've got our CH2, and we've got our CH2, we've got our CH, right? And it should be 2. There's one typo in this book. Oh yeah, no, it's the, oh, they flipped it around. Let me flip it around for you so it doesn't get messed up, okay? CH2 and H3. I would do NH2, but they're going to leave the plus on there. It's fine. Okay, so if I were drawing this molecule, I would, even though it would be kind of incorrect, I would leave the kink in here because then you would see which one came off the end, right? We didn't remove the one on this end, so I'll circle it. How about that? We're going to remove this one, okay? And we're going to add an H to balance it out. So this gets an H added. So this is the change. Add one H, right? Remove this. So we've gone from glutamate, glutamic acid, right, down to GABA. And you can call it GABA. Okay, it's gamma aminobutyrate. All right, so
there's one extra CH2 in that chain.
What did I do? Did I?
You need one more in there.
Oh, I see. Thank you. All right, it's hard to. There we go. Let me raise. I'll raise my hand. I move it. So this H thing is added. This H. Okay.
So how would you say that? You're adding a hydrogen to the
So
final?
okay. So I would say you're removing this carboxylic acid group, and then you're adding a hydrogen to this carbon because it needs 4, right? Carbon is very.
But you're saying this car? Are we naming that?
Oh, I'm sorry.
Or?
So what used to be our alpha carbon, that's now something else. Because it's no longer an alpha carbon. It's no longer a chiral carbon, right? So this particular carbon is a chiral carbon in our amino acid structure because it has, unless it's attached to one that only has H. But this one is chiral carbon. So it's got an H, a carboxyl group, an amino, like your, NH3+, right, an amino group, and then your R group. When you move down, this is no longer a chiral carbon because it's attached to 2 different H's, and then the amino group, and then the R group. We have removed the carboxylic acid group from what used to be our alpha carbon.
So, but if we just underline it and write added a hydrogen, we don't need to describe.
Yeah, you don't have to describe. If you give me the molecule, that's all the describing I need.
Oh. Okay.
You don't even have to tell me that you added a hydrogen, as long as you balanced your carbon right there.
Okay.
It's just sometimes when people take this off, they forget that carbon needs 4.
Yeah.
Carbon does not exist without 4. So that's how you have to balance it out.
Okay.
It acquires a hydrogen.
And we just have to write GABA, we don't have to write the alpha.
Yeah, just write GABA.
Okay.
Because when you're reading